Now we have just finished the discussion of electromagnetic induction, which is what? Which is whenever magnetic field or flux, they are same thing, changes across a conductor or any loop, there is a production of current by itself, which is called induced current. So that is the complete electromagnetic induction. Current, change in flux produces current. That phenomena is applied in generator. So what is a generator? Generator is a device which produces electricity. So suppose we have magnetic field. I am drawing the bar magnets. This is my bar magnet. This is north pole, and similarly I have a south pole here. Between these magnets, these are my loop, the current, because magnetic lines of force are from north to south. Done? This is magnetic line of force. Inside this, I have placed my loop, which is going to what? Produce current. We are going to rotate it by ourselves, and current is going to get produced. In motor, what happened? We flowed the current across it and it got rotated by the effect of magnetic field, exactly the vice versa thing. So here, this loop will be rotated and we are going to get current across it. How? See, again we have the same sort of thing, that is carbon brushes and slip rings. So here my first ring, extend this wire, second ring, and then we draw the output from these two rings. So we have a resistance which is called load resistance LR and a switch, or you just take output from here across load resistance. This is output. So this is a block diagram of generator. In some books you won't find this type of commutator arrangement, because this diagram which I have drawn is basically an AC generator. That's why I left a space there. So let's explain it first, and then we are going to talk whether how this AC and DC generators are converted into each other. Now let's say this loop is rotated like this. Okay, so I'll have this. Sir, can you please pass on me the phone? This loop is rotated in this direction. I'm going to show it with my phone. Okay, yeah, exactly. Just one second. See, this is the direction of, this is how my loop is placed, right? Now I am rotating it in this direction. So you just have to see the boundary, nothing else. And I'm rotating it in this direction. So what will happen? The flux linked across this loop is going to change, because the magnetic field, when the magnetic field is in this direction, because of the presence of north and south polarity magnets, when the loop is a straight, there is no line passing through it, it is going along. But when it is perpendicular, you will see the lines which they are actually crossing the loop. So what will happen? The flux change will cause and current to produce in it, and the direction of flow of current is gained by what? Right hand thumb rule. So let's apply right hand thumb rule. This part is going upwards, it is coming out. So motion, magnetic field is in this direction, so current is vertically inwards. That means the current will flow in this direction. Similarly, if I'll mark this ring as R1 and R2, I'll get current out from R1 and R2. So here I am writing the polarity, and above I'll be making the output current. See, you'll understand it. Right now current is going in this direction, that is from R1 to R2. So R1 is positive and R2 is negative. But once one complete loop is done, for example from like this to this, so what will happen? Once this complete loop is done, this part, this ring is going to go around and will be connected from this point. This point will be here, but current still manages to flow in the same direction, because current is only depending on the direction in which the loop is rotating according to right hand thumb rule. So current will still go from this point to this point, that is, call it clockwise. Current will still flow clockwise, but right now current will be flowing from R2 to R1. Why? because this part is here and this part is here. So current is going from R2 to R1. That means R2 is positive and R1 is negative. Then the first cycle gets repeated, and that is why. Now one more thing. If I draw the output, suppose I have to draw the output of current. Current is depending on what factor? Current is depending on only one factor. That is how many number of lines are changing in what time. So if we keep the time factor constant for now, let's not complicate it. So keeping time factor constant, that is, it is being rotated with a constant velocity, but the number of lines are changing in what sense? This was the initial phase when there is no line passing through it. It will ultimately reach a point where the maximum lines are flowing, and then it will diminish back to zero. That is, field is again going along, not passing across it. So the current or the voltage will start from zero, it will reach a peak point and will come down to zero. But then the current flows in similar manner but in opposite from R2 to R1. So current will be in this direction, and then this, and then this. So the output is an AC curve. This is the graph of alternating current, and this is why it is called an AC generator. But if I change the commutator arrangement, see how I am changing commutator arrangement. I have deleted this ring, okay, and in this ring I have done it into two parts. So now instead of slip rings, I converted it into split rings. So output is taken from these 2 points only, okay. So again R1 and R2. Now this time, initially if R1 was positive, I'll write it down again. Initially if R1 and R2, initially R1 was positive, R2 was negative, because the current is flowing from R1 to R2. After one rotation, this part will leave this ring and will get attached to R1, and this part will get attached to R2. That means current would still flow from R1 to R2 only. The only thing is changed, which is these two wires, they change their position. Now this wire, which was initially connected to R2, got connected with R1, but current still flows from R1 to R2. So this R1 still remains positive, this one negative, again positive, so negative. The graph would be something like this. From 0 to maximum to 0, then 0 to maximum to 0, and 0 to maximum to 0. So this is a DC, this is what? A DC generator. Why DC? This is a fluctuating DC. Direct current means the current which cannot go in reverse direction. That means current cannot have any negative component. Here, current was having negative component. That means current was changing its direction depending on the propagation of those loops, right? That is why this is an AC generator graph and this is a DC generator graph. So this generator, just by changing the commutator arrangement, can be converted into both AC and DC generator. So I suppose these concepts are very much clear to you now, the concept of electromagnetic induction.